On November 2nd, amateur astronomer Gennady Borisov noticed a strange object near the Sun, one that is barely held by our star's gravity. Simply put, it's almost interstellar. Most likely, it didn't come from the depths of the galaxy, but from the outskirts of our own system, from the Oort cloud. But that's not even what surprised us. That same week, another interstellar object, 3I Atlas, flew past the Sun. Its interstellar nature is practically beyond question. A speed of about 60 kilometers, which is hundreds of times faster than any man-made vehicle. Even the fastest race cars are like turtles in comparison. The new object, however, looks different. It's almost not gravitationally bound to the Sun and appears to have come from the periphery of the system on a very steep, almost plummeting orbit. It passed very close to the star, and only then was it noticed. A logical question arose. Could it be related to 3I Atlas? If Atlas is an ordinary comet, a fragment could theoretically have broken off from it. And if we consider a more fantastic scenario, a technological object, then it could have deployed a probe towards the inner regions of the system. But calculations show that the new object's orbit is almost perpendicular to Atlas's orbit, and their closest approach was hundreds of millions of kilometers apart. Too far to suggest a direct relationship. Most likely, it's just a coincidence. Two unusual bodies appeared near the Sun almost simultaneously. Although if the object is controlled, it could have changed its trajectory in such a way that the paths appear independent. We received a question from a viewer. If Atlas came from the nearest star, how long was it traveling? If we're talking about origin in the Oort cloud, the journey from its outskirts to its current position would have taken about 8,000 years. That's the time from the beginning of human writing to the present day. On a cosmic scale, that's an instant. But if the object is truly interstellar, then everything depends on where it was ejected from and at what speed. Perhaps it flew for billions of years, being a fragment of a long-dead star. Our calculations with a student show that its age could be 7 to 10 billion years. It might be older than the Sun. If it's an artificial object, then any estimates are meaningless. The creators could have been nearby, and the journey was short, or conversely, the message was sent long before humanity appeared. Another question. Why do we see interstellar guests so rarely in the first place? If we assume that such wandering objects move randomly, rocks, ice, comet nuclei, then according to calculations, there could be on the order of 10^15 interstellar bodies within the volume of the solar system, right up to the boundaries of the Oort cloud. Imagine, for every object that flies into the region where we can see it, there are a quadrillion more in the invisible part of space. This suggests that many stars must produce a huge number of such objects. And much about this question is still unclear to us. If Atlas turned out to be a ship, I would only welcome it. For humanity, it would be a test of our humility. We are used to thinking we are the pinnacle of development, but an encounter with an advanced civilization could change a lot. It would give us a new perspective on our place in the universe. Of course, if such an object hit Earth, the consequences would be terrible. Similar events have already wiped out the dinosaurs. But the forecasts are reassuring. Atlas will pass us at a distance of about 250 million kilometers in mid or late December. This will allow us to observe it through powerful telescopes. Even now, the images show several jets emanating from the nucleus. They could be caused by the sublimation of ice under the Sun's heat, or if we consider an exotic option, the operation of technical engines. One can be distinguished from the other by the speed of the ejecta. Artificial thrust provides significantly higher speeds than natural sublimation. Some colleagues are surprised by my suggestions about Atlas's possible technogenic nature, saying that most astronomers out of habit consider any unusual body to be a comet. But when we study objects at the edge of the universe, we choose the most probable model, and it rarely affects our daily lives. Here it's different. Within our system, even a small probability of risks requires serious consideration. Therefore, any anomalous objects must be studied as thoroughly as possible. Comet experts are used to seeing comets. They are trained on huge data sets, specifically about them. I propose to broaden the framework, to include the possibility of technological origin in the analysis. After all, we ourselves have launched probes into space, meaning this category of objects really exists. There are also practical problems. For example, when 3I Atlas passed by Mars, it was photographed by high-resolution orbital cameras, but access to the images was blocked due to a bureaucratic pause during a government shutdown. Scientists didn't get the data in time, and such delays can cost us key information. I believe that bureaucracy should not block scientific data, if only to plan further observations. And finally, about the Galileo project, which I oversee. Its goal is to systematically observe the sky and collect data that military and intelligence structures often classify as unidentified objects. This could be a matter of national security if the objects are artificial and produced by an adversary. But if they are extraterrestrial, that's far more interesting. We are building a network of observatories. 3 stations are already operational, and we analyze millions of objects using machine learning to identify those whose behavior doesn't resemble any known device. We also organized an expedition to the Pacific Ocean to retrieve samples of an interstellar meteorite from the seabed, confirmed by space services. The materials are still being studied. All of this is part of a larger program to not miss a single opportunity and to investigate every lead. People often ask about the future. Parents write to me telling me that their children, watching these events, want to become scientists. For me, that is the greatest reward. The feeling that a new generation will unravel the mysteries that still elude us. And I will be happy to return to the air before Christmas to share new data and fresh observations.